I'm Mark Price. My current position is Senior Lecturer in Computing at the University of Worcester. Prior to that, I was working for the BBC in their Research and Development department. I worked there for about 18 years. I've worked on a range of projects, but the most recent project, the final project that I worked on, was the one in collaboration with the University of Bristol on high dynamic range video. And dynamic range basically means the ratio of your darkest darks in your scene or your image and your brightest or your lightest whites in that image. It means that you've got more details in the darks and more details in the lights that are visible to the viewer. Strictly speaking, there is a scientific definition for high dynamic range imaging, and that refers to what is practically infinite dynamic range, so we can have whatever light intensities represented that we want. But in practice, obviously, that isn't feasible. So consumer sets usually have a dynamic range of about 7 f-stops. In theory, it's about 8. It can be a little bit more than that. But due to various things going on in the system, noise, etc., you usually got about 7 stops of usable dynamic range. If we switch over to a high dynamic range, that becomes undefined essentially, because it's more than that, but no one has really decided what it really means exactly. But cameras can be something like 14 stops dynamic range, and some manufacturers claim up to 18 stops dynamic range. So that's considerably more than the 7 stops we're working with for consumer displays. There's 2 techniques for capturing high dynamic range video at the moment. The first, the simplest technique, is making the sensor collect more light. So each sensor site needs to collect more light. To do that, it needs to be physically bigger. The implication of that is that you either have to make your entire sensor bigger, and therefore your lens needs to be larger as well, or you keep the same size sensor and you have a reduced resolution. So there's always a compromise, and here the compromise is between resolution and dynamic range. The second method, which is the traditional way of doing HDR imaging, is using a standard sensor, using a normal sensor that hasn't been adapted in any particular way, is to capture multiple images per frame. There is a cinema camera out there that does things that way. It has a single sensor and it captures each frame from that sensor twice. The first time it captures it, it just reads the sensor early, so it continues to capture and it doesn't clear. So then you can work out your expected dynamic range to be the dynamic range of your sensor plus that difference, that relative difference in f-stops. Of course, it never works out like that because the sensor has noise within the system that you have to take account of. That's capturing high dynamic range material. For displaying it, then you have a different challenge. Essentially, a dark means that your pixel is turned off. But even if your pixel is turned off, the surface still has a reflectance. It's still reflecting light that's present within the room, ambient light. So if you've got brighter whites, it's shining out those bright whites, it's reflecting off all the surfaces in the room, including the viewers, and it's bouncing back onto the blacks, onto the black pixels. And so the dynamic range that you planned your display to have isn't the same as what it really has in reality, and it will vary according to the material that you're playing through it. So you can never actually have a fixed dynamic range to your display. The other issue with high dynamic range displays then is that the industry hasn't really agreed on any particular standard. No one's agreed on what is the best highest brightness, and no one has agreed on what is the best lowest darkness. When there's an agreed standard, you can then grade to a reference display and know that what you're grading is going to look good on all of the consumer sets that you're sending that material to. The present situation then within the industry is we have these devices, these cameras that capture at higher dynamic range. It's becoming almost standard, if you like, to have, certainly in the movie industry, cameras that capture at a higher dynamic range than the display that material is ultimately going to be displayed on. This means that any material that you're capturing is ultimately going to be reduced in dynamic range one way or another. You're going to lose something through that process. There's nothing in the workflow at the moment that allows you to maintain that dynamic range. However, that said, it's very useful to professionals to have that extra dynamic range that's been captured because it gives them more to work with. It gives them more information that they can play with. It means that when mistakes are made, then you're more likely to be able to recover from it. For example, if you set your f-stop of your lens slightly wrong, you're able to essentially recapture that information and change its f-stop value electronically. Of course, ultimately, what we'd really like is for the display devices to have a dynamic range that is on a par with those higher-end cameras. The question is, how high will that dynamic range be? Because the higher the dynamic range, the brighter, ultimately, your images are going to need to be. And I think there is a limit, really, to what the viewer is willing to accept in terms of brightness.